Hence, we can discuss the fourth use of dimensional analysis. The dimensional analysis will help you to find the dimensions of different constants involved in a physical relation. And before coming to the problematic situations, നമുക്ക് രണ്ട് പ്രധാനപ്പെട്ട കാര്യങ്ങളെക്കുറിച്ച് നമുക്കൊന്ന് ഡിസ്കസ് ചെയ്യാം. അതിൽ ഓർത്തിരിക്കേണ്ട രണ്ട് പോയിന്റ്സുകളിൽ ഒന്ന് ദ പ്രിൻസിപ്പിൾ ഓഫ് ഹോമോജനിറ്റി. ആ പ്രിൻസിപ്പിൾ ഓഫ് ഹോമോജനിറ്റി പറയുന്ന കാര്യം നമ്മുടെ മനസ്സിലേക്ക് എപ്പോഴും വരട്ടെ. അത് പറയുന്നത് ഇങ്ങനെയാണ്: ദ ഡൈമെൻഷൻസ് ഓൺ ബോത്ത് സൈഡ്സ് ഓഫ് എ ഫിസിക്കൽ റിലേഷൻ ആർ സെയിം. സോ ദാറ്റ് മീൻസ് m raised to p, l raised to q, t raised to r is equal to m raised to a, l raised to b, t raised to c. That means we have to write as p is equal to a, q equal to b, and r equal to c. The dimensions on both the sides are equal. രണ്ടാമത് നമ്മുടെ മനസ്സിൽ വരേണ്ട ഒരു പോയിന്റ് എന്ന് പറയുന്നത് we can add or subtract only with the same type of physical quantities. വളരെ പ്രധാനപ്പെട്ട കൺസെപ്റ്റാണ്. Addition and subtractions are possible only with the same type of physical quantities. By using this concept, we can try to solve some problematic situations, even applicable for the board exam too. See, look the question. In the gas equation, it is given as P plus A by V square into V minus B equal to RT, where T is the temperature, P is the pressure, V the volume. Then what are the dimensions of constants A and B? That's a question. So from this relation, we want to find the dimensions of A and B. So we can use two concepts, above said two concepts here. But here the addition terms are there. That means here the P, the pressure, and A by V square are added together in the sense we can say the dimension of P should equal to the dimension of A by V square. So from that we can easily find the dimension of A is equal to the dimension of pressure into the volume square. What is the dimension of pressure? We can easily use the concept as equal to the force by area into the volume square. So we know the dimension of the force as m L T raised to minus 2 by L square into, the volume got the dimension of L cube. So raise square, it become L raised to 6. So that is equal to 1L cancel. So it become L raised to 5. So AM L raised to 5 T raised to minus 2. So that is the dimension for A. A good question for entrance exams too. And similarly, if you look into the second term, that is it is given as V minus B. That means the subtractions are possible with the same type of parameters and hence the dimension of the volume should equal to that of B. It is another very important concept. So the dimension of B, take the value as m raised to 0, L raised to 3, T raised to 0. So we get the answer for the two questions. We can go through the another very good question. See, the velocity v of a particle is given in terms of time t as v equal to at plus b by t plus c. So the dependence of velocity on time are given us. Then we have to find the dimensions of A, B and C. So we can use the above said concepts again, and here by using that principle of homogeneity, then we can write the velocity dimension should be equal to at dimension should equal to as b by t plus c. So by using this concept, so at first we can try to find what is the dimension for A. By using this one, we can write the dimension for A is equal to the dimension of velocity by t. We know the dimension of velocity is what? As L t raised to minus 1, that division by t, and we get the value as L t raised to minus 2. So the answer for A. Then what is the dimension for B and Z? Look here in the denominator, the t is added to z. We know the additions are possible with the same parameters. So we can, the dimension of c should be equal to t. The dimension of small t is nothing but the capital T. So we get the parameter c also. Then we can link with that velocity with this term. Then we can easily write that velocity got the dimension of b by t plus c. But we know the numerator, the dimension of b by the dimension of c. We know the t plus c got the dimension of the same, and hence we got the value as c. So we can find the dimension for b. So that is equal to the velocity into the dimension of c. It is given as t. So v is what? L t raised to minus 1 into t. So you get the value as L. So we get the solution. A very important problematic situation as keep in mind. Then we can move to another one or two questions again. See, a good question. It is given in a relation that alpha by t square equal to fv plus beta by x square. Then find the value of the dimension of alpha and beta. A good question. So here also we can use the same concept once again. That means here the dimension of alpha by t square should equal to f into v. Therefore, the dimension of alpha is equal to fv into t square. So that is equal to, you know, the dimension for f. That is m L t raised to minus 2 into the velocity L t raised to minus 1 into t square. That is equal to, see here the m alone, but L, the 2 contribution 1 plus 1 as a 2 ml square. Then t raised to minus 2 t square cancel. So ml square t raised to minus 1. So that is the dimension for alpha. By using the same concept, we can use this, we can link between them. Then easily we can find that beta. That means f into v got the same dimension as that of beta by x square. That means the dimension of beta, take the value of the dimension of fv into x square. That is equal to mlt raised to minus 2 into lt raised to minus 1 into x square as l square. So equal to em into l raised to 4 into t raised to minus 3. So that is the answer. So we can easily find the answers for the problems. The next very good question is waiting. Very good question. It is given that alpha equal to fv square by beta square into log to the base e of 2 pi beta division by v square. Then find the dimension of alpha and beta. That is the question. But you should know the very, very important concept that, see, the trigonometric ratios, the sine theta, the tan theta, the exponential functions, e raised to x, then logarithmic functions, log to x, all the brackets are dimensionless. The very important concept. So by using this concept, see, it is a log function, and hence we can say 2 pi beta by v square equal to m raised to 0 l t raised to 0. That means we can say any quantity raised to 0 become 1. Therefore, so any quantity raised to 0 become 1. So 2 pi beta got the dimension of v square. So there is no dimension for the constants, and hence beta got the same dimension of v square, l t raised to minus 1 square. So beta got the value l square t raised to minus 2. Then our aim is to find what is the dimension for alpha. So it is the dimensionless quantity. Then the dimension of alpha should equal to the dimension of f v square by beta square. That means the dimension of f, already we know that m l t raised to minus 2 into v square is what? V square, that is beta. So 1 beta cancel. So that division by beta, that is equal to m l t raised to minus 2. That division by that beta is what? L square t raised to minus 2. So t raised to minus 2 cancel. 1L cancel. So alpha got the value equal to ml raised to minus 1 only. So the answer for the problem. And keep in mind, it is a very important concept in the trigonometric ratios, exponential functions, logarithmic functions. Both the brackets are dimensionless. We can use that concept to solve the problems. So we can just discuss one more problems regarding this type to find the physical constants. An examination question. See the position x of a particle at a time t is given by x is equal to v0 by a into 1 minus e raised to minus at, where v0, a are constants. Then find the dimension of v0 and a. So the very important question. So here also, you just look into the concept, into the bracket. There is an exponential term is there. We said all the brackets in relation to that are dimensionless. So we can say a into t got no dimension. That means a got the dimension of 1 by t. So that is equal to t raised to minus 1. So that concept we can use again here, the principle of homogeneity. So x should got the dimension of v0 by a. So our aim is to find what is the dimension of v0. That is equal to x into a. So that is equal to x is nothing but L into a as t raised to minus 1. So v0 got the value as L t raised to minus 1. So that is a good concept. So while using these concept, we can solve the problems that are very, very important one while considering our entrance examinations. Thank you. God bless you.